So, good morning to the viewers and my dear students. As last time, I was discussing about the various concepts on physical optics. So, today let me brief, because last time it was that time was not been permitted. So, I could not able to complete the various theories of the lights. Now, so that is when you talk about so called the physical optics, that is the optics is a branch of physics which we deals with the propagation of the light and its various properties and its various effects. So, the optics is basically it is divided into two types, a geometrical optics and a physical optics. In physical optics, so we studied about the reflections and refractions, dispersions and so on, whereas in physical optics we studied about the interference, diffraction and polarization, etc. Now, whereas in case of the geometrical optics, and the geometrical optics, this phenomena is based on the particle nature of the light. Now, whereas in physical optics, these phenomena it is based on the wave theory of light. Now, as we know that light is a form of energy. So, if this energy if it falls on our eye, now it makes the object appears. So, this is how we call this light is a visible light, and there are some lights like say for example infrared, ultraviolet you have. If these lights are present, but it makes the object invisible, hence these lights are referred as invisible lights. Now, there are various theories has been put forth to understand the behavior of this light, or I can say that in a crude way what actually this light is. So, there are theories, there are four theories. Newton has given his theory is called as the Newton corpuscular theory, and Maxwell has given his theory is called as electromagnetic theory, and there is a Planck's theory quantum theory, and Huygens also has given his theory is called as the wave theory. Now, in brief, what actually this Newton's corpuscular theory? Corpuscular means it is the minute weightless particles are called as corpuscular. So, in the year 1678, what Newton thought that, so this light it is made up of small minute particles, and these minute particles which has been emitted from a highly burning body, or you can say that is a luminous body. You take a luminous body, any burning body, so these particles are emitted from all the directions, and these particles are not to be seen to us because their size is so small. So, our eyes are not sensitive to detect, and hence these particles he has called as corpuscle. Now, the question is why these concept has flashed into the mind of Newton's, why he has considered as particle, because certain experiment has shown that is the experiments like reflections, refraction and dispersion, where in this phenomena the light will travels in a straight line. When light travels in a straight line, so he thought that the light could be made up of small minute particles, because these particles only it will travel in a straight line. Now, say for example, you take a ball, a body, you just throw it in a straight line, that means the body moves in a straight line. Or in case of a ball, you just take a ball and hit it towards a wall, the ball moves in a straight line, after hitting to the wall again it get rebounds. So, that means if a body has got certain mass, that means this body can only move in a straight line. So, this is the idea and flashes in his mind. So, then he said that it is made up of minute particles, and again the different colors of the lights. Now, he says that the different colors of the light it is based on the different size of the particles. And why this theory fails? The drawback of the theory is that is the according to the Newton. So, that is when the source of light emits small particles, this masses goes on decreases, but no such changes in mass is been detected. This is one of the failure. Then according to this theory, the velocity of light in a denser media, now say in case of water, it is higher than that of air. So, as we know that the velocity of light in a rarer media is almost 3 lakhs kilometer per second. Now, whereas in a denser media it is very less, but according to Newton it is other way. Now, according to this theory, greater is the temperature of the source, that is the body which is emitting light, greater is the agitations of a molecules, and hence higher velocity will be parted to this small minute particle called as corpuscle. But experimental evidence shows, it doesn't shows that the velocity of these particles remains almost same. So, this is the some of the drawbacks of this theory. And later on in the year 1679, there is one more scientist, he is a Dutch physicist. He proposed a theory and called as the wave theory of light. Now, according to the Huygens, so he said that the light is supposed to transfer from one point to the another point in the form of waves. I think I told you, you just remember last time, the wave in the sense, you just imagine how the snake moves in a zigzag way. So, in a similar way the light also moves in a zigzag way. So, it is a two-dimensional movement. Why he has considered, that is, he thought that whatever this light which has been emitted, for their propagation, that means for the movement of the light, a media is required. He assumed, so there is a media present, and the media he called as ether. Ether is the media. So, what is the idea behind in considering the media is, now say for example you take a stone and just drop it into water. What happens? The ripple starts, and this ripples completely, it will encroach the entire the surface of the water. So, in a similar way what Huygens thought, that whatever the light which has been emitted from these luminous sources, and these light it travels in a media. So, that means he thought that the media is required for the propagation, and the media he is considered as an ether is a medium. So, this theory, that is the wave theory of the light, it successfully, it will obeys certain phenomena like what is called as the diffractions, polarizations, interference and all this. But the drawback of this theory is, there is no existence of experimental evidence for the presence of this media called as ether. So, this is the one of the drawback. So, hence this theory fails. The next comes the Maxwell electromagnetic theory. So, again further in the year 1873, so James Clerk Maxwell, he proposed a theory, and his theory, it is based on certain fundamental equations of electricity and magnetism. So, those equations were called as Maxwell equation. According to him, the light, it is totally, it get fluctuating means it goes on shakes, it vibrates. So, that means it is nothing but the vibration of both electric and magnetic field. So, now is this electric and magnetic field vibrations combined together? No, it does not combine together. So, both of them will be perpendicular to each other. So, this is how you can see the figure over here. So, that is, so just imagine, so this is the one fluctuation, this is the one fluctuation, there is a another fluctuation, and both of them are perpendicular. As both of them are perpendicular, so this is the propagation. So, this is the movement. So, this is what Maxwell thought, that according to him, so this fluctuating magnetic field, that is, it is consisting of both electric as well as magnetic, so together, combined together. So, he referred this is called as electromagnetic theory of light. So, in this electromagnetic theory of light, so one thing correctly he assumed that the velocity of the light is almost in vacuum is that of the order of 3 lakhs kilometer per second. Now, what are the characteristics of these electromagnetic waves? One of the characteristics of this electromagnetic wave, so these electromagnetic waves can propagate, that means it can move in a material media and also in a free space, which is true. The second characteristic, the variations in both electric and magnetic field occur simultaneously. So, therefore, they attain their maxima at the same place at the same time, whereas the velocity of the electromagnetic waves, it depends entirely on the electric and magnetic property of the medium in which the wave travels. The electromagnetic waves are produced by accelerating charges. Now, finally, the direction of the electric and the magnetic fields are mutually perpendicular, as well as the direction of propagation, all the three are mutually. So, therefore, electromagnetic waves are transfer in nature, which is true. Now, next theory is a very important theory proposed by Max Planck in the year 1901, and the theory is referred as quantum theory of light. Now, according to this theory, that is so called this light or the radiation, it is not continuous, but it is made up of a tiny packets of energy, and these tiny packets of energy he has referred it as a quanta. That is, this quanta he has called it as photons, and this photon, it possesses energy. The energy of the photon is given by E is equal to n h nu, where n is an integer, where h is Planck's constant, whose numerical value is 6.626 into 10 raised to minus 34 joules second, and whereas nu is the frequency of the incident photon. The important property of this theory, that is the radiations photons, are the energy of the photons depends upon the frequency. So, that means as the frequency of the incident light is more, so definitely the energy of the photon also increases. Next is the photon travels with a velocity of light. So, the velocity of the photon is almost equal to the velocity of light. So, that is of the order of 3 into 10 raised to 8 meters per second, and these photons are electrically neutral. The next is, when photon hits the material, both energy and momentum are conserved. So, this is one of the interesting property possessed by the photons. Now, that interesting property of the photon has been expressed in the form of certain derivations. Now, according to these derivations are, so that is, when the energy of the photon, it is given by an expression E is equal to h into lambda. Now, whereas according to Einstein energy relation, that is, the energy is also given by E is equal to mc square. So, according to Einstein, that is the Einstein says that a body having a mass m moving with a velocity c that totally the body will be converted to energy. So, that is E is equal to mc square. Now, according to Planck's, the energy of the photon is given by E is equal to h into nu. Now, let us compare this energy. So, that is finally we get mc square is equal to h into nu. Now, here nu is the frequency. Then what we do is, let us try to keep the mass one side and rest of the thing you can transfer here, or we can also do that. See, mc square is according to energy relation, this is equal to h nu. So, now this one of the c you can transfer over here. So, that means that is, see, m into c, mc into c is equal to h into nu, or this m into c, it is called as the momentum. Momentum p is equal to h nu divided by c, and what is nu is the frequency. We know in a well known equation, the velocity of a wave, that is, it is given here, the frequency of the wave, it is given by the velocity of the wave divided by lambda. So, if you can substitute this here, then finally we get an expression here, that is the momentum p is equal to h into lambda. So, that means, so this expression is a very interesting expression. It is been given by de Broglie according to de Broglie expression. So, that is, so he has connected the particle property of the light to the wavelength. So, here left side you have a particle property, on the right side you have a wave. So, that means, so this is a very interesting expression. So, that will tell that the radiation, that is the photon, it will behaves like a particles and it also behaves like a wave. So, this theory, it is referred as the dualism. So, that means the light possesses a dual theory. It is having two properties, that is the particle nature as well as the wave. So, this theory which obeys the law of phenomena, like we have what is called as a photoelectric effect, the Crompton effect, and the Raman effect, and so on. So, this is the one of the full proof theory, that is the wave theory as well as the particle theory. It can able to explain the various concepts, even including the particle nature of the light, the phenomena of light, refractions, diffractions, dispersions, and whereas the wave nature of the light is interference, polarization, diffraction, photoelectric effect, Crompton effect, and all this. So, hence there is what is called as, there is a dualism. So, the particles possess dual property. So, this is the some of the basic concepts of this theory. So, now let us try to understand the wave nature of light. So, that is there as per the syllabus are concerned. The first phenomena, very interesting phenomena, is an interference of light. What is this interference? So, interference is defined as when two light waves, if they are tried to superimpose, then the resultant wave whose amplitude, or I can say the intensity of the light. So, whenever the superposition occurs, the intensity of the light either decreases or increases compared to that of the individual waves. So, this type of phenomena is referred as what is called as interference, or interference can also be referred as the redistribution of light energy due to the superposition of two or more light waves are also known as interference of light. In this case, the resultant amplitude, whenever the two waves try to cross each other, so we get a result. Now, where the resultant amplitude is sum of the amplitude of the two waves. Such a type of interference, if it occurs, then it is referred as what is called as constructive interference. So, that is, let us imagine that this is the wave, this is the wave moving in certain direction. Suppose there is one more wave having the same origin, it also moves in the same direction. If these two waves meets in such a way that this part of it and this part of it get coincides, then the resultant wave will be having a greater amplitude. So, it is like this. So, the amplitude of this wave is equal to the amplitude of this and the amplitude of this. Suppose A is the amplitude of this, B is the amplitude of this, then the resultant wave will have an amplitude of A plus B. So, whenever this type of waves try to crosses with each other, so it results in an interference, and this type of interference, it is referred as what is called as constructive interference. So, there is one more type of interference now which will takes place whenever the waves, let us imagine this is the wave moving in one direction, let us imagine there is another wave moves in other direction like this. Now, here the crest of this wave, it is not meeting, it is almost out of phase. The crest of this way, it will be out of phase with this, it meets the trough. So, then the resultant wave will be almost a dead wave, no wave is formed. So, that means both the way, I can say in a crude way that both the wave will get cancels with each other and resultant wave is a dead wave, no wave. So, if this is the case, then this type of interference is referred as destructive interference. Now, let us try to understand that whenever the interference in case of constructive interference will take place, the amplitude is almost equal to the sum of the two waves, whereas in case of destructive interference the amplitude is, say, the difference between the amplitude of the two waves. Now, just see this is one video, so you can understand this is a very interesting concept. So, this is where the reflection will take place, and here you have the reflection taking place, and these two phenomena represents the wave. Now, whereas you can see there is a diffraction taking place here and there is a interference of the light. So, this refers the wave nature of light. Here this is the one source of light is coming away, another source not. This is the point where both the lights will superpose with each other, it results in an interference here. So, this is how the interference will take place. Now, where we can say that it is nothing but the rearrangement of the energy. Now, see, there are the two waves are moving together, here the amplitude will increase. Now, here see the same thing is repeated here, where both the waves are moving together, it meets at this point and this. So, this is you can see at home also, you require a large vessel of water. There if you can put one light object, a concentric circle takes place, and one more light object, concentric circle takes place, that results in that. Now, this you can observe during the when you observe the sea. So, where these types, where the amplitude, that is the wave, may try to increase it because of the constructive difference. So, once again you just see that. So, there are two pins. So, where you can see that the amplitude will increase. Now, let us try to prove mathematically that the resultant displacement of the two waves when it will undergo interference. So, what could be the resultant amplitude? Now, for this is now let us consider there are two waves. Let us assume that so their frequency almost the same, and let us assume that both the waves will have same amplitude and they are all moving in the same directions. Here we have considered this is the one way and this is another way. Now, both the waves are moving in the same direction. So, this is the same directions. Let A represents the amplitude of this wave 1 and B represents the amplitude of the wave B, second way. Now, here so if we can able to recollect the equation of I mean the in case of the wave theory, the displacement of the wave you have studied earlier, the displacement of the wave, it is given by an expression y is equal to a into sin omega. I think you might have studied this in the form of r y is equal to r into sin omega t, where here r represents the amplitude. So, here we have considered A is an amplitude. So, there are two waves are here. Let y 1 is the displacement of this wave having an amplitude into sin into omega t. Similarly, let y 2 is another way having an amplitude b into sin into omega t plus phi. Now, what is this phi is? Now, phi here is, it is referred as what is called as the phase difference between the two waves during the superposition. So, that means what is this phase difference? To understand this phase difference, so that is, let us imagine the phase difference will tell you actually the presence of the particles. So, say for example, here we define what is called as one is a phase difference, other is the path difference. To understand this, the meaning of phase difference and the path difference is, let us imagine that there is a circular tracks. Imagine a circular tracks. On a circular track, let from A one horse starts moving, and on a one more track, let from B on a two different tracks. So, there are two horses are starting from two different points. Both the horses are moving in a same direction, say with the same speed, and after completing one round they will come to the same point, but they will try to maintain this distance. So, this is referred as what is called as the path difference, or I can also do that. Let us imagine a wave started from this point, another wave also started bit late. So, what is the path difference? This is the path difference. And whereas the phase difference, and this phase difference, it is either it is expressed in terms of the time or it is expressed in terms of the angles. So, that is, let us imagine a body moving in a circumference circle. Let us divide this into x axis and y axis. Let a body start from this point let it make certain angle theta. Now, at the starting point, suppose you try to measure in terms of angle, the angle is say 0 degree, here the angle is say 90 degree, here it is 180 degree, again 270 degree, again 360 degree. So, suppose this, if I try to express these angles in terms of radian measure, so this will corresponds to pi divided by 2 radians, and this will corresponds to say pi radian, and say this will correspond to say 2 pi radians. Suppose a body starts from this point, say when it is at 0 degree, then you can start down your watch. Let us say when the time is here is say is equal to t is equal to 0. So, to complete this complete one revolution, say the time it will take is say 1 second. So, that means this angle, the location of this angle I can also express in terms of time. So, that means when a body starts from this point, it completes one round, say it will take time t. When it comes to this point, say it will take time t by 4. When it comes to this point, it will take time t by 2, like this. Now, let us imagine a body is moving in a circumference circle. Now, when a body comes or when it covers an angle, when it covers an angle of 90 degree, then we can say the body is located at an angle of pi by 2 radians, or in terms of time I can say the body has consumed t divided by 4 time to reach this point, and so on. So, that means in order to locate a body, so you can locate the body either in terms of the angle or in terms of the time. So, this is how we refer, this is called as the phase difference, and it has got a definite relation between the phase difference to the wavelength. To complete one round, so it will complete one cycle. So, let us say the lambda is the distance travelled by the wave. In order to cover this lambda, it will take some 2 pi radian, it covers an angle of 2 pi radians. So, that means, so this is nothing but the path difference, and the previous is nothing but the phase difference. So, this is the path difference and this is the phase difference. So, you can have a relation, the relation is that the path difference is equal to, it is the phase difference by the lambda, or phase difference you want lambda divided by this. So, if you can remember this, so you can able to. Now, this is so this is what the meaning of the phase difference. So, now let us imagine there are two ways when they try to crosses with each other. Let us assume while it crosses, it will have certain phase difference. Even if it has certain phase difference, this phenomenon of interference will take place. Now, the mathematical calculation says, so y is the resultant, it is given by addition of the two waves, that is y1 plus y2. Now, you substitute the value of y1 here, y1 is taken as a into sin omega t, and whereas y2 is taken as b into sin omega t plus phi. Now, when you can club together this, now using a well known relation as you have studied in your trigonometry, that is you know that the sin of a plus b, it can be splitted as sin a into cos b plus cos a into sin b. Now, by doing so, so here you just notice this. Now, this is in the same rhythm like this. So, you have a sin and a cos, then you have a cos and a sin. So, that means these can be replaced as sin of a plus b. So, by doing so, so we get an expression, this is an expression. Now, here this value, if you can substitute this value as say r into cos theta, and whereas this value b into this you can take it as r into sin theta. So, what is theta we have considered? Theta is the phase difference between the resultant wave and the first wave. I think so, you better do not get it confused here. We have used the phase phi here and again we have used theta here. So, theta is the phase difference between the resultant wave and the first wave. Now, this is a very simple calculations where finally you end with, that is the resultant is equal to this. So, now this is again in the form of sin A cos B cos A sin B. So, this you can write as sin of A plus B. So, that means R into sin of omega t plus phi. So, this is the relation finally which has been obtained whenever the two waves will interface with each other. Now can we use this relation? Now, here R is the magnitude of the resultant. Can we use this expression to show that there are two types of interference? There is a constructive interference as well as destructive interference. Yes. Now, let us say let us try to find out the resultant magnitude of the two waves first. To find out the resultant magnitude, now let us, we have already assumed earlier, that is the R into cos theta is taken as A plus B into cos of phi, and whereas the R sin theta is taken as this. Now, what we can do is, now we can square both the sides. So, if we can square this, so it is done here, squaring this, and now if you can square, this is in the form of A plus B whole square. So, that results into what is called as A square plus B square plus 2AB, that is 2AB into cos phi into square of this. So, you call this as relation 1. Similarly, let us square the other expression. So, that is squaring that you get B square into sin phi square is equal to R into this. So, this is, now you can call it as relation 2. Now adding this relation 1 and 2, if you can add the relation 1 and 2, so you get, this is the next expression. This is the next expression when you add it. Now, just look at here, that is in this expression, let us try to take out B square as a common factor. If I take B square as a common factor, so that results in cos square phi plus sin square phi this side. So, toward the right hand side, if you can take out R square as a common factor, that results in what is called as cos square theta plus sin square theta. Now, you know the well known trigonometry, the well known relation, that is sin square theta plus cos square theta is equal to 1. Now, substituting this value here and substituting the values here, and finally, you get an expression, that is R square is equal to A square plus B square plus 2AB into cos phi. So, finally, transfer this the square of R. So, finally, you get R is equal to square root of, this is the expression, this is the final expression to find out the magnitude of the resultant. And this is one of the similar expressions you might have studied, that is in vectors, the whenever the two vectors add together certain angle. So, you are getting a similar expression where R is equal to square root of P square plus Q square plus 2 PQ into cos theta. So, if you can remember this, I do not feel that this will be a difficult process. So, you can remember this is almost same. Now, here A is the amplitude of the first wave and B is the amplitude of the second wave. So, this is the resultant of the two waves. Now, considering this expression, whether these expressions holds goods mathematically the two types of interference, that is, one is a constructive interference, other is a destructive. Let us see the whether that expression, that is r square is equal to square root of a square plus b square plus 2 ab into cos theta, it matches the constructive interference. Now, here, so you just remember, so we discuss that that is during the time of constructive interference, the two waves will meets at one point. The two waves will meets at one point and the resultant wave is of a larger amplitude. Now, here, now let us try to find out at what are the phase difference or at what are the positions. So, the constructive interference will take place. So, that is when these two waves will meet each other in such a way that the crest of this wave will coincide with the crest of the other wave. So, then we can say that these two waves are said to be in same phase. So, that is, let us try to find out that. So, this is a general expression, that is to find out at what phase difference. So, these waves will satisfy the above conditions. So, when that phase phi is equal to 2 pi into n, where n is an integer, it takes the value from 0 and so on. Now, suppose if you substitute, if the value of n is equal to 0, so this results in 0. So, that means when n is equal to 0, the phi is equal to 0, that means the cos of phi is 1. So, that means at the beginning, whenever both the waves will coincide, so it results in a interference. The second is, suppose if n is equal to 1, if n is equal to 1, again phi, you get 2 pi, 2 pi will corresponds to 360 degrees, right. That means even when they are at 360 degrees, this phenomena will take place. So, now that is this, even when the phase difference is 0, the constructive interference will take place. Even when the phase difference is at 2 pi, this will take place, and 4 pi and so on, this continues. So, now let us try to find out the path difference. The path difference is given by, this is the formula to find out the path difference. So, when n is again an integer, it takes the value 0, 1, 2, 3 and so on. Now, here when this is 0, we can calculate when n is equal to 1. So, lambda, you get 2 lambda and 3 lambda and so on. So, now the above expressions, if we can use this above expression for these values. Now, that is you consider the first value now, when cos of phi is equal to 1. So, that is at 0. So, that means this entire expression, it is going to be 2ab, 2ab. So, that means so you have an expression a square plus b square plus 2ab. So, this you can write it as a plus b whole square. Now, here the square root and the square cancels each other, then finally you get, that is a plus b. So, that means whenever the constructive interference will take place, then the magnitude of the resultant is sum of the two. So, this is the expression, mathematical expression. It is also proves that the magnitude of the resultant is nothing but the sum of the two. I think it is clear. Now, let us go for the condition for the destructive interference. So, in a destructive interference, as I told you, whenever the two waves try to crosses over each other and the resultant wave is a dead wave, no wave. Suppose when we talk about the light, when the two light from two sources are coming together, at some point as it falls, so the altogether there is no brightness, it is totally dark. Now, whether this in a similar way as we did it for the maximum, intensity. Let us see whether this expression can holds good for the destructive interference. Now, again once again. So, this is the general formula to find out the various phase angles. So, this phi is equal to 2 pi 2 n plus 1 into pi, where again n takes an integer. If you go on calculate the values, then similarly you get the values like, that is pi you get, this is the possible angles pi, then at 3 pi, and this is 5 pi and so on, all the numbers is odd integers you will get. Now, similar to this, if you can calculate the phase difference is given by, this is an expression. Now, again n will take say values. Now, the possible the phase differences to obtain this destructive interference is say lambda by 2 or 3 by 2 lambda or 5 by 2 lambda and etc. So, this is the values. So, now let us take this is the value first, let us try to test whether this expression holds good. Now, in this expression again you consider in place of cos of phi is equal to -1, when cos of phi is -1. So, that means this is going to be a square plus b square minus 2ab. So, this you can write it in the form of a minus b whole square. Now, here what happened, again this square, this will get cancelled, again results in this. So, that means whenever the two waves it try to crosses each other, so that means the resultant amplitude will be the difference between the two. If the amplitudes are same and the resultant amplitude is 0, so that means it results in no way. So, that means, so during the destructive interference I can say that whenever the two light waves crosses each other destructively, so it results in no light, both the light will get cancelled. Whereas, in case of the constructive interference, whenever the two light source meets at one point, at that certain point the intensity will be maximum. The intensity of the light is almost equal to the sum of the two. Now, what are the conditions so that we can have interference? The condition for the interference is that the two source which you select, it should be a coherent. What do you mean by coherent? Coherent in the sense both the source should be similar. This is one of the important conditions for interference. If the two sources are different, however even a small difference, so then the interference does not takes place. So, both the source should be coherent, then only the interference phenomena will takes place, otherwise no. The another condition is the distance between the two coherent source must be as small as possible. Now, here in the classroom you might have seen there may be one tubelet glowing, there may be another tubelet glowing, or in a house there may be plenty of lights here and there. No, the different sources are giving different light, but in the room or in your houses you will not find this so called as interference. The reason is the two sources of light, they are not so close. If they are close on us, there is a possibility that interference may take place. But another thing is the sources of light which are being there in the houses, they are not coherent source. And one more point is the interference wave must have same or nearly same wavelength and the time period. This also been very important. And the interference wave must have same amplitude. So, this will ensures a good contrast between the brightness and the darkness. So, suppose if the both the waves will have similar, if the amplitudes are almost same, then better is the effect. So, you can able to see some spots are or some area is totally bright, it is because of the constructive interference, and some areas are totally dark, it is because of the destructive interference. Another condition is the two slit must be narrow. What is meant by two slit here? That means it is the slits are considered as the two sources of same frequency. When we will perform the experiment to show this effect of interference, I think I will tell you this. Next is the two waves must interference at a small angle for a better interference. So, that means the phase difference should be minimum, so that we can get a good interference. The next is the source must emit a light of the same frequency, that was I earlier told you. So, the source must be a coherent source. If the interference waves are polarized, again you are going to study this phenomena polarization, there the meaning is further is going to be clear. If both the waves must have a same plane of polarization, when I take up polarizations I will tell you this effect. And finally, if the two interference beams propagates at almost the same directions, or their wave front must intersect at a small angle. Now, that is, in order to have a very effective interference, so these are the conditions must for the interferences, then only we can able to observe this phenomena. Suppose if these conditions are varies, the phenomena will take place, but it is not a effective one. Now, here one of the important expressions to determine what is called as the fringe width. What is this fringe width we mean? Now, I said about there is a whenever the two waves will crosses each other, so then it results in a constructive and a destructive interference. So, here the distance between the two consecutive bright, that is means where there is a constructive interference will take place, or in the dark where the destructive interference. So, this difference, so this is referred as what is called as the fringe width. So, that means the distance between any consecutive bright or the dark fringes are known as the fringe width. So, there is a expressions to determine this, and there is a derivation. It is very important as far as the point of exams are concerned. So, I hope so I may derive this in the next class. So, till that, so this is a very interesting topic, not only a knowledgeable, very important as far as exams are concerned. Now, maybe it is a bit difficult. I have tried to convince you in a way I could. So, better you go through this, right. Till that, so I will leave. So, please take care. Next time we will try to discuss now how to obtain the expression for the fringe width. Thank you very much.